Have you ever looked at a soaring skyscraper, a bustling hospital, or even, a beautifully crafted home, and found yourself wondering, how did all of this actually come together?
Yeah, it's a natural question.
We often picture a singular visionary, right? A kind of master builder, overseeing every hammer swing, every architectural detail. It's a really compelling image.
It truly is. It's a romantic vision, isn't it? The lone genius shaping the built world. But the reality of how our modern environment takes shape, well, it's far more intricate.
Hmm.
It's really a testament to a profound and ongoing evolution in the construction industry. Those days of that single, all-encompassing master builder are by and large behind us now.
And that's precisely our deep dive today, the rise of the subcontractor. We're going to unpack the fascinating journey from that era, the master builder era, to the complex, highly specialized construction model we see all around us today.
Yeah, it's a huge shift.
And this isn't just about the mechanics of building, nuts and bolts. It's an essential look at the operational reality of how modern buildings actually get constructed.
Exactly. Our mission today is to explore that historical shift, the underlying economic and practical reasons that really drove this fragmentation.
Right.
And critically, the undeniable benefits you get from bringing in highly specialized expertise, but also, importantly, the significant management challenges it creates for today's general contractors.
Okay.
You'll learn about the contractual realities that kind of bind this intricate system together, and ultimately why the general contractor's role has fundamentally transformed into something quite different, more like a master coordinator.
Get ready for some genuine aha moments, because what you learn today will absolutely change how you view every structure around you. It's really a story of incredible human ingenuity, problem solving, and a whole lot of moving parts.
It really is.
So let's unpack this. Before we dive into the modern intricate dance of, dozens of specialized companies on a single job site, we really need to set the stage. Let's understand the world that came before it. Because the era of the true master builder, well, it wasn't just a myth from history books, was it? For a very long time, it was the prevailing reality.
No, absolutely not a myth. And what's truly fascinating here is that for millennia, from ancient empires constructing grand temples and aqueducts to medieval craftsmen erecting these towering cathedrals across Europe,
Yeah.
the concept of a single guiding hand, someone deeply skilled across many disciplines, that was indeed the dominant model. Think about the medieval master of works.
Okay.
During the 13th to 15th centuries, architecture wasn't seen as this fragmented process of distinct trades like we think of it today. It was an integrated craft. As the renowned architectural historian Viollet-le-Duc described it, it was an art so complete and connected and so entirely subject to the control of a corporate body.
A corporate body. So not just a skilled individual, but almost like a self-governing entity of craftspeople who held all the knowledge together. That's a stark contrast to today.
Exactly. It wasn't just a figure of speech. These master builders were truly central to every aspect of construction. We know, for instance, of figures like Maître Robert de Luzarche and later Thomas and Renaud de Cormont.
Right.
They were so integral to monumental projects like the Amiens Cathedral that their names and faces were literally inlaid in white marble within the labyrinth of the nave.
Wow.
This act directly defies the kind of modern notion of anonymity in large-scale construction. These architects and craftsmen, they formed a powerful corporate body that possessed its privileges and franchises, allowing them to operate freely and governed itself in the domain of arts without external interference.
Amazing.
And a critical detail often overlooked is that construction during this period often relied on, well, small materials which could be raised and laid without the assistance of machines, human strength being sufficient.
Right. No cranes, no heavy machinery like today.
Exactly. That's a stark, almost unimaginable contrast to today's heavy machinery and specialized equipment that you see on every site.
It paints such a vivid picture of a craft where the vision and the execution were just completely intertwined, almost like a single organism controlling everything. And this holistic approach wasn't just limited to the Middle Ages, right? It went back further.
Oh, not at all. If we look further back to the classical architectural vision of the ancient Romans, as described by Vitruvius in his famous 10 books on architecture, we see architects holding an incredibly comprehensive view. They weren't just sketching facades or, overseeing a few key tasks. They were meticulously designing temple proportions, dictating precise column thicknesses.
Like down to the millimeter.
Well, maybe not millimeter, but pretty specific. For example, 1/7 of their height for a column's thickness at the bottom, and they even specified the exact width of openings for atria.
Incredible detail.
Yeah.
The Roman architect, as Viollet-le-Duc also noted, adopted a different method in designing a vaulted structure and one covered with timber, respectively, demonstrating a truly holistic understanding of structural systems right from the initial plan. The architect essentially held the solid edifice present to his mind's eye from the very ground plan.
A complete integrated vision. The designer understood every practical implication of their drawings.
Precisely.
And this kind of integrated mastery, this idea of one person holding it all together, even stretched into the early industrial age, didn't it? When we think of those impressive engineering feats of the 19th century, figures like Isambard, King, and Brunel often come to mind as these singular geniuses.
They absolutely do, yeah. These early industrial precursors like Isambard, King, and Brunel, he really epitomized a form of integrated mastery in the 19th century that truly pushed the boundaries of what was thought possible. He was a polymath, really. He combined profound engineering skill with exceptional architectural gifts to design and build incredibly complex structures. We're talking about the iconic Chepstow and Saltash bridges.
Huge projects.
Massive feats of engineering for their time, absolutely. And gigantic ships like the Great Eastern. Now, while Brunel's projects were undeniably large-scale and involved components like the Saltash trusses that were actually prefabricated on shore.
Ah, okay, so a hint of specialization there.
A hint, yes. It certainly points towards the early emergence of specialized fabrication, but they were still fundamentally conceived and largely overseen by his singular, encompassing vision. He retained a highly centralized control over his grand designs.
So he was still the mastermind.
Very much so. He wasn't just an inventor. He was deeply involved in every aspect of execution, from the drawing board right to the construction site, pushing technological boundaries and solving problems across disciplines in a way that's...
Well, it's hard to imagine one individual doing today on that scale. It sounds like an impressive testament to individual genius. Truly remarkable. But even with figures like Brunel, there must have been, well, the first cracks in unified control starting to appear. When did this highly integrated model, this era of the master builder, begin to show signs of strain? What started to pull it apart?
Yeah, that's a crucial turning point. The first subtle but significant cracks in this unified control, this sort of artistic and practical independence, they began to appear towards the close of the 15th century.
Okay.
Viollet-le-Duc observes that external influences started to impact the architects' and craftsmen's control. You had nobility returning from travels in Italy, starting to impose foreign styles, tastes, aesthetic trends.
Ah, so fashion dictates.
Kind of, yeah. Rather than simply accepting the local artistic tradition, the clients started pushing back. This led artists to accept a style of art imposed upon them, which was a critical shift. This marked an early and crucial erosion of the architect's absolute independence, their ability to act freely and govern themselves as that corporate body we talked about. The client, or the patron, began to dictate aesthetics and styles, effectively challenging the master builder's comprehensive vision.
Interesting.
This was a fundamental departure from the preceding centuries where, as one critic put it, the triumphs of architecture were confined to those epochs when this art has really been under the control of artists and when they have been able to exercise it with independence.
So once that control started slipping.
The seeds of fragmentation were sown.
Yeah.
And the stage was being set for a much larger, more profound transformation in how we build.
So we're talking about a world where the vision and execution were, if not entirely singular, then certainly highly integrated. But the world, and specifically the act of building, inevitably changed. The scope of human ambition, the tools at our disposal, it all started to demand something new.
Indeed. The triumph of a singular integrated architectural vision was always, in a sense, confined to those epochs when this art has really been under the control of artists.
Right.
And when they have been able to exercise it with independence. Once that independence began to erode, once external demands and new complexities grew, the stage was definitively set for a fundamental shift, one that would irrevocably redefine the builder's role.
Okay, here's where it gets really interesting, I think, because the master builder didn't just vanish into thin air. Their role evolves dramatically. So what specific forces reshaped construction into the highly fragmented, specialized system we know today? What was the fundamental shift?
That's an excellent question, and it really gets to the heart of it. If we connect this to the bigger picture, the shift is a direct pragmatic response to a massive increase in complexity, driven by an explosion of new technologies, advanced materials, and escalating, often contradictory demands placed on buildings themselves. It simply became, well, no longer feasible for one individual or even one comprehensive firm to master every single aspect, from foundation to finish.
And that complexity starts with the buildings themselves, right? They're not just walls and a roof anymore. They're incredibly sophisticated machines in many ways.
Precisely. We've witnessed an explosion of building complexity unlike anything before. Modern buildings are vastly more intricate than their predecessors, requiring an array of sophisticated, interconnected systems that demand deep, distinct expertise.
Like what, for example?
Think about electronic safety and security systems. These aren't just simple locks and keys anymore.
No.
They include incredibly complex alarm systems, advanced electronic surveillance, sophisticated intrusion detection equipment, integrated fire alarm, and suppression systems. These highly specialized components are even categorized under their own Division 28 in industry standards.
Wow, its own division. So these are entire fields of engineering and installation on their own, just for security.
Yeah.
What about the physical structure itself? Has that become much more complex too?
Oh, absolutely. The building envelope alone is a masterclass in specialized knowledge now. It involves intricate weather protection strategies, understanding water-resistant barriers to prevent moisture intrusion, and crucially, managing internal water vapor.
Right, condensation and mold issues.
Exactly. If that's not properly addressed, it can soak insulation, corrode anything metal, and even lead to rot and structural failure. Stuart Brand highlighted that. And Joseph Staberek emphasizes the need for specialized knowledge in managing humidity, especially in high humidity areas, to prevent pervasive issues like mold growth and compromised indoor air quality.
And beyond the envelope, the internal workings are just as complex, like, say, the air we breathe inside, HVAC systems.
Absolutely critical, and far from simple vents and furnaces. They involve specific duct designs to ensure proper airflow, advanced filtration systems for air quality, contaminant control protocols, all crucial, particularly in varying climates. Even the structural elements have advanced dramatically. We're now dealing with sophisticated techniques like precast hollow core concrete deck systems, post-tensioned two-way flat plates which use very high-strength steel wires anchored to the slab edges.
Complex engineering.
Very complex. Light-gauge steel framing also requires specialized installation techniques, vastly different from traditional timber framing. Each of these calls for its own set of skills, tools, and deep understanding.
So the sheer complexity of modern materials, systems, performance requirements, it all necessitated a new approach.
Yeah.
What about the tools themselves? Technological advancements and specialization in the processes used to put all this together. How did that factor in?
That's another critical driver, and it's been transformative. The advent of sophisticated machinery itself marked a new epoch, as the visionary architect Le Corbusier put it. The ability to build was no longer solely about human strength and simple tools. This led to an entirely new paradigm. For instance, building information modeling, BIM, has emerged as a game changer.
Definitely hear a lot about BIM.
You do. But the key insight here is that even within BIM, there are specific applications tailored for architectural design versus fabrication. That perfectly illustrates this growing split between holistic design and highly specialized production. BIM tools are now so advanced, they produce specialized drawings for different fabricators and installers.
So the digital model isn't just one picture.
Exactly. It's 100 different instruction sets for different trades, all needing to coordinate.
That's incredible. It sounds like the future of building might involve even more digital craftsmanship, maybe less hands-on work on site.
It absolutely points that way. Looking ahead, thinkers like Neil Gershenfeld and Ratty and Claudel predict that digital fabrication capability and reach will improve by many orders of magnitude. They foresee a future where making objects will become more like compiling and executing code than like laborious, specialized, and time-intensive woodcraft in a carpentry studio.
So 3D printing buildings almost.
On a component level, certainly. It foreshadows an even deeper reliance on specialized fabrication subcontractors, integrating digital design with physical output at unprecedented levels. Imagine custom-engineered components being printed or robotically assembled off-site, each part needing specific expertise to design and produce.
All of this, the increasingly complex buildings, the advanced technology, it just sounds like it became way too much for any single person or even one comprehensive company to handle effectively.
That's the core of the problem of scale, risk, and diverse demands. As projects grew exponentially in size, complexity, and the demands placed upon them from strict energy efficiency standards to aesthetic versatility, a single entity could no longer realistically master all the necessary trades.
And crucially,
Crucially, they couldn't assume all the associated risks involved in such a massive undertaking. This inevitably led to a natural fragmentation into distinct parties, each bringing their focused expertise and managing their specific slice of the risk.
makes sense.
The result is the distinct, intricate ecosystem we see today. Owners, designers of all kinds, general contractors, and then subcontractors and fabricators, each playing specific, often highly technical roles.
So the general contractor isn't just the main builder anymore. They've essentially become
How?
the central nervous system of this complex, multi-organism entity.
That's a great way to put it, precisely. The general contractor's primary role in the modern era is, as explicitly identified in industry standards, that of a master coordinator of these specialists. It's a profound shift from doing it all to orchestrating it all, making sure all these disparate but highly skilled parts work in concert towards a singular vision. It's less about knowing how to lay every brick, and much more about knowing who can lay the bricks best and how to make sure their work aligns perfectly with the plumber, the electrician, the HVAC guy, and everyone else.
Right. It's about management and coordination above all else. This shift towards specialization sounds both inevitable and incredibly practical. So, beyond the sheer complexity we've discussed, what are the core economic and operational reasons that led to this widespread adoption of the subcontractor model? It must offer significant advantages to have become so universal.
You're absolutely right. If we connect this back to the bigger picture, the fragmentation wasn't merely a passive consequence of increasing complexity. It was a deliberate, strategically advantageous evolution, driven by clear economic and practical incentives. This system offers compelling benefits that a unified master builder simply couldn't achieve at the modern scale or level of demand.
I can imagine reduced financial risk for the general contractor, GC, being a huge one, maintaining a massive, varied workforce in-house for every single trade year-round. That must be incredibly costly and inefficient.
It's an enormous factor, yeah. By subcontracting, GCs avoid the immense overhead of maintaining that large, diverse, in-house workforce. Think about it. They don't have to carry the salaries, benefits, training costs for electricians, plumbers, roofers, glaziers.
When there's no work for them that month.
Exactly, when there isn't a project that needs them all simultaneously. Instead, they can procure specialized services on a project-by-project basis. This significantly optimizes labor costs and resource utilization.
Makes perfect business sense.
And then here's a crucial insight for you, the listener, especially if you're ever an owner involved in a project.
Oh.
From a legal standpoint, the contractual structure typically insulates the owner from direct claims against subcontractors.
Oh, interesting.
While the GC is ultimately responsible for the overall project and its quality, this chain of command reduces the owner's direct risk and streamlines communication. It pushes the direct management of sublevel performance onto the GC.
Okay, so the buck stops with the GC, legally speaking, for the owner.
Largely, yes. GCs also gain crucial flexibility to package contracts and choose delivery methods like design build or traditional design bid build that best manage their financial exposure and project timelines. It gives them strategic options.
So GCs are essentially running a highly flexible project-based business model. And this naturally leads to, I suppose, increased expertise and efficiency of specialty firms. When you focus on just one thing, you become really, really good at it.
Yeah.
Indispensable even.
That's precisely it. This is where the magic of specialization truly shines. Subcontractors, by focusing intently on a narrow field, whether it's, say, electronic safety and security, or highly specialized foundations work involving precise soil analysis, seismic considerations, intricate footing design, they can achieve a much deeper level of knowledge, skill, and practical experience. This depth is recognized as professional services in industry standards. This intense specialization allows them to invest heavily in highly specific equipment, advanced, niche training for their people, and refined, often proprietary, processes that a generalist firm would find difficult and financially prohibitive to maintain across all trades.
Yeah, you can't own all the expensive specialized gear.
Exactly. This focus leads directly to greater efficiency, higher quality, and often faster execution within their specific domain. It really embodies the idea of specialized craft. They are also better positioned for process tailoring, adapting their specific methods to the unique demands of each project.
Tailoring. How so?
Well, large or critical projects, for instance, can justify more refined, often cutting-edge processes because the specialist has that inherent depth and experience to draw upon. They can bring the absolute latest techniques to bear when needed.
So it's not just about raw expertise, but how they can deploy it strategically across many different projects. That speaks to optimized resource allocation and responsiveness, doesn't it?
Exactly. This is a significant operational advantage. Specialty firms can deploy their specialized crews and their expensive, specialized equipment across multiple projects simultaneously.
Right. Keep the crews busy, keep the machines running.
Maximize utilization, yeah.
Yeah.
And amortize their substantial investment costs much more effectively than a single GC attempting to retain all those trades in-house. Imagine a specialized curtain wall installer or a complex roofing company. They move from job to job, ensuring maximum efficiency for their niche.
Makes sense.
This agile structure allows for much quicker mobilization of specific expertise exactly when it's needed on a project. This can accelerate overall project timelines and improve responsiveness to demands or unforeseen changes. It's particularly crucial in complex phase construction projects, where sequential work needs careful management to avoid bottlenecks.
And with the increasing complexity of regulations we touched on earlier, I imagine specialized firms are much better equipped to handle navigating regulatory complexity. It feels like every trade has its own massive rulebook now.
Without a doubt. Building codes today are incredibly complex. They cover highly specialized areas, and they often have regional variations, too.
Oh, yeah.
We're talking everything from occupancy groups, how many people can safely be in a space, and allowable building heights, to extremely detailed egress requirements, how people exit safely in a fire.
Crucial stuff.
Absolutely. Specific fire resistance ratings for materials and assemblies, even granular applications like the precise mix and curing of cement plaster. These regulations are constantly evolving, and keeping up with them for every single trade is, well, it's a full-time job in itself. Specialized subcontractors are uniquely equipped to navigate and comply with these evolving, granular regulations within their specific trade. They ensure the work is not only expertly done, but also legally compliant and meets all safety standards. For a general contractor to have that depth of regulatory knowledge for every single trade would be virtually impossible.
So what you're really saying is it's not just about building better, maybe, but building smarter, faster, and with significantly less risk, especially financial risk for the general contractor and ultimately the owner. It's a pragmatic, almost unavoidable response to the sheer scope of modern construction.
Precisely. This model acknowledges that in a world of ever-increasing technical demands, a single entity simply can't hold all the necessary deep expertise anymore. It effectively leverages collective, specialized intelligence to deliver complex projects that would otherwise be impossible or prohibitively expensive and risky to build effectively and efficiently. It's like a distributed intelligence model for construction.
A distributed intelligence model. I like that. This entire system sounds like a fundamental trade-off, though. You get immense depth of skill and efficiency on one side, but then you create this whole new universe of management and coordination challenges on the other. It's truly a double-edged sword, isn't it?
That's a very perceptive way to put it, yeah. And it raises an important question about managing any complex system, really. Specialization brings immense value, undoubtedly, but it fundamentally transforms the nature of project management.
How so?
It becomes about optimizing the whole by empowering these highly skilled parts, and that inherently brings both brilliance and burdens. We wouldn't build our modern world without this specialization, but it comes with a definite cost in terms of coordination effort and complexity.
Let's start with the brilliance and the pros. What are we really celebrating about these high-level, focused skills that specialists bring? What makes them so indispensable?
Well, the pros are significant, and they are the reason this system evolved and persists. First, there's the unparalleled depth of knowledge. Specialists bring an almost encyclopedic understanding of their trade that a generalist simply cannot match.
Can you give an example?
Sure. An HVAC subcontractor doesn't just install ducts and air handlers. They understand complex, balanced ventilation systems with heat recovery, the nuances of air pressure zones, the critical importance of preventing mold in cooling coil areas. They know the subtle differences in airflow dynamics that impact comfort and energy efficiency.
Right. Things a GC wouldn't necessarily know in that detail.
Exactly. Similarly, a foundation specialist goes far beyond just digging a hole. They deeply understand diverse soil properties, intricate foundation settlement dynamics, specific footing designs for various load types, how to pour concrete in extreme weather, drawing on deep expertise. This level of detailed, practical knowledge ensures the building performs optimally from the ground up, minimizing long-term issues.
And that incredible depth of knowledge and just doing the same thing over and over again, that practice translates directly into superior work, doesn't it? Better quality.
Absolutely. This leads directly to superior quality and precision. Through the repeated application of their craft across countless projects, specialized firms develop an extremely high level of precision and quality that generalists would struggle to achieve. As J.E. Gordon succinctly put it in his book Structures, engineers' stuff must work and go on working safely and economically. This dedication to excellence and robust performance is really a hallmark of true specialization. Mastery of a specific task leads to a demonstrably higher standard of execution and, hopefully, longevity.
And these specialists must also be at the forefront of what's new and cutting edge in their fields. That's where innovation really happens, right, in those niches.
They absolutely are, constantly driving innovation. Specialists are frequently at the forefront of adopting and developing new technologies and methods within their niche. Think of a facade specialist working with revolutionary new glazing materials or smart home integrators developing custom interconnected systems.
Yeah.
We mentioned BIM before. Those applications are tailored not just for architectural design, but specifically for fabrication needs, enabling highly optimized production processes. Even the concept of fab labs, local workshops using specialized digital fabrication tools, suggests how focused expertise fosters new solutions and pushes the boundaries of what's buildable.
And finally, modern buildings have such stringent requirements, especially around things like sustainability and energy performance. Specialists must be absolutely key there too, I imagine.
Indeed, they are essential for meeting complex performance standards. Modern demands for sustainable construction, like achieving rigorous Energy Star benchmarks or adhering to strict SHRA standards for energy performance, indoor air quality, thermal comfort.
A long list.
It is. And it requires an intricate knowledge of materials, systems integration, performance modeling that only dedicated specialists possess. This expertise is critical for designing and constructing truly green buildings that perform as intended. It's not enough to simply want a green building. You need specialized experts to actually deliver it effectively.
Okay, that's a powerful and compelling case for the brilliance of specialization. But you mentioned burdens earlier. What are the cons? The significant management challenges that inevitably come with orchestrating so many highly specialized independent entities? This is where the GC's job sounds truly Herculean.
This is where the general contractor's role truly shines, yes, but it's also where they are tested every single day. The primary burden, the one that can keep GCs up at night, is undoubtedly coordination complexity.
Just keeping everyone on the same page.
And on schedule. Managing dozens of separate companies on a single, fast-paced job site becomes the GC's paramount challenge. A construction project isn't a neat linear process. It's a highly interlocking system with stocks, flows, and feedback loops, as systems thinker Danella Meadows described it.
What does that mean in practice on a job site?
It means a seemingly minor delay by one subcontractor, say. The concrete pour is pushed back a day due to unexpected bad weather, can ripple uncontrollably through the entire schedule.
Right.
It impacts the framers waiting for the slab, then the plumbers waiting for the framing, the electricians waiting for the plumbers. Every subsequent trade gets pushed back. It's a domino effect.
So it's like a complex choreography where one dancer missing a single step throws everyone else off rhythm.
Yeah.
Can you give a really concrete example of this kind of clash happening?
Absolutely. Imagine this very common scenario. The HVAC ducting is designed to run through a specific ceiling space. But the structural engineer's bracing is already installed right in that path because their plans weren't perfectly coordinated. And then the electrician has routed their main conduit directly through the only remaining clear area.
Oh, boy.
Right. This isn't just a minor tweak. It often means significant reengineering, costly rework, major delays, and potentially expensive change orders. A technical example of this, often seen with BIM, is the real-world lack of interoperability between Revit and CAD MEP models.
Different software not talking to each other.
Exactly. Highlighting actual technical barriers between specialized design platforms used by different trades, often requiring various workarounds just to make the digital plans align, let alone coordinate the physical construction. This kind of clash, digital or physical, is a daily reality a GC has to untangle.
And with so many people and companies involved, communication breakdown risks must be absolutely constant despite everyone's best intentions. Misunderstandings must happen all the time.
All the time. With multiple parties, clear, constant communication isn't just important, it's absolutely paramount. Yet, misunderstandings can easily arise, leading to costly conflicts where parties declare, "I never agreed to that," or, "You recall, I took exception to that."
Finger pointing.
Exactly. This usually happens when precise written documentation isn't maintained or conversations aren't confirmed in writing. The need for meticulous and detailed notes, a virtual paper trail of every decision, every change, every agreement is critical to avoid these disputes and ensure everyone is truly aligned on scope and responsibilities. It's honestly a full-time job in itself, just managing the information flow.
Even with all that specialized expertise we talked about, a GC still needs to keep a close eye on the final output, which brings us to quality control oversight. How do you ensure quality when you're not the one actually doing the work?
That's a crucial point, and it's a delicate balance, absolutely. While each subcontractor is responsible for their own quality and has their own internal checks, the GC must continuously monitor contractor compliance with the quality level expected for the project and ensure adherence to all the contract documents, the plans, and specs.
So inspections.
Yes, but often it goes beyond just visual inspection. It includes arranging and coordinating field testing, which is not a part of individual contractors' work scope.
Like what kind of tests?
Things like concrete strength tests, air tightness tests for the building envelope, specialized equipment calibrations, commissioning HVAC systems,
Yeah.
independent verification. It's about ensuring the overall product meets the standard, even if you're not the one performing each intricate task yourself.
And there's just the sheer unpredictability of it all, right? The managing interdependencies and fluctuations inherent in any large, complex project.
Oh, notoriously so. Projects are plagued by dependency and fluctuations, often leading to late orders or unforeseen material shortages, as Eliyahu Goldratt famously explained. The GC must constantly manage a huge range of variables, potentially in the 50,000 or who knows, maybe it's 50 million range, across a complex project. It highlights the immense difficulty of maintaining control in such a highly fragmented environment. A sudden change in material availability, an unexpected soil condition found during excavation, even a local labor dispute. Any of these can send shockwaves through the entire carefully planned schedule.
So the GC is constantly anticipating and reacting to these moving targets.
Constantly firefighting sometimes, yes.
And finally, managing financial risk mitigation across multiple entities must be a logistical and, I imagine, legal nightmare at times.
It's certainly multifaceted and a core component of the GC's challenge. Identifying, assessing, and mitigating risks becomes far more complex when dealing with numerous independent companies, each with their own financial health, safety protocols, insurance coverage, and potential liabilities.
Right. Each sub is its own business.
Exactly. This includes managing potential work stoppages due to strikes, dealing with odd lot sizes for specialized materials that mess up schedules, unexpected special delivery costs, even securing and tracking premiums for payment and performance bonds from each and every subcontractor. Each one introduces a unique layer of independent risks that the GC must anticipate, manage, and ultimately bear responsibility for, as they are the prime contractor.
So it's just this constant balancing act, leveraging the incredible power of deep expertise while tirelessly combating the chaos and potential for error that can come from having so many independent moving parts. It sounds absolutely exhausting.
It is exhausting, precisely. And that balancing act is where the role of the general contractor truly comes into its own in the modern construction landscape. They are the essential linchpin, making the entire specialized system function often against immense odds. It's a demanding but incredibly vital role in making our built world happen.
Okay, if it's all about coordinating so many specialists, the legal and contractual side of things must be incredibly robust. It has to lay out exactly who does what and who's responsible for what. It sounds less like a building site sometimes and more like a carefully engineered legal and bureaucratic maze.
That's a perfect analogy, actually. A maze. What's fascinating here is how the contractual framework provides the absolutely necessary structure for this complex collaboration. It's designed to bring order to potential chaos.
Right.
Yet it inherently demands absolute clarity in defining responsibilities and scopes of work to prevent disputes down the line. It's a precisely engineered system designed to manage complex interactions and ensure accountability from the top all the way down.
So how does this contractual hierarchy and chain of command actually work in practice, especially in terms of protecting the owner or the person paying for it all?
Okay, the modern construction system is built upon a very clear contractual hierarchy. At the top, the owner establishes a prime contract directly with the general contractor. The GC is often referred to as the prime contractor.
Makes sense.
The GC then, in turn, enters into multiple subcontracts with specialized firms for specific portions of the work: an electrical subcontractor, a plumbing subcontractor, a roofing subcontractor, and so on down the line.
Creating that chain.
Exactly. This creates a distinct contractual chain of command, where the owner generally only has a direct legal relationship or privity of contract with the GC. And here's a critical insight for you, the listener, especially if you ever consider a large construction project. The owner typically will not usually be able to claim for its own benefit any rights in favor of the main contractor under any of the various subcontracts.
Okay, what does that mean practically?
What this means is that the GC is your primary legal shield in many ways. They are the direct point of contact and responsibility for all the work performed by their subcontractors, even though the ultimate benefit, the finished building, accrues to you, the owner.
So essentially, if the plumbing goes wrong, you, the owner, talk to the GC, not directly to the plumber who installed it. The GC then has to deal with their subcontractor.
That's generally how it works, yes.
It simplifies things for the owner, but places immense responsibility squarely on the GC.
Exactly. And to further maintain these clear lines of responsibility and avoid messy multi-party litigation, express language is often required in subcontracts to indicate any benefit conferred upon the owner. Often, parties even explicitly exclude the operation of the contracts, Rights of Third Parties, Act 1999.
Okay, that sounds very specific and legal.
It is, but the key takeaway is that these measures are intentionally put in place to prevent unintended third-party claims, reinforcing the GC's central role as the single point of accountability. It means the GC is the one truly on the hook to deliver the complete finished project as promised.
So that legal structure is there to clearly delineate who's accountable to whom. This implies that the critical importance of a well-defined scope of work is absolutely non-negotiable. It has to be crystal clear, airtight.
Airtight is the perfect description, yes. A clearly defined scope of work is the absolute bedrock for avoiding disputes between trades and ensuring project success. Each subcontractor's responsibilities must be clearly defined in the scope of work and the contract language. No ambiguity allowed.
And that means tons of paperwork, I assume.
Oh, incredibly detailed documentation, often running hundreds, even thousands of pages on large projects. Detailed working drawings are sometimes required to clarify the contract drawings and specifications or the chosen construction method for specific work packages. These provide immense value to the field personnel who need precise instructions.
Right.
Moreover, outline specifications that might start fairly broad must be thoroughly fleshed out during design development to ensure the proper product designated as well as the materials specified are in the acceptable price range and meet all performance requirements. It's a meticulous process.
Because ambiguity leads to
conflict. Exactly. When subcontract agreements or vendor purchase orders are being finalized, it is not uncommon to hear, "I never agreed to that," or "You do recall, I took exception to that." This leads to costly conflicts and delays, usually because the scope wasn't clear enough from the very start. Precision prevents problems.
And even with the best planning and the most precise contracts, changes inevitably happen on any big project. So managing change in expectations must be built into this contractual web somehow, anticipating the unpredictable.
It absolutely must be, because no project, especially a complex construction project, ever goes exactly according to the initial plan. Even for things called alternates, which are options for additional work or different materials within contracts, there's a requirement for precise definition and clear deadlines for acceptance or rejection at specific stages in the construction cycle so as not to disrupt or delay progress.
Proactive management of options.
Exactly. This proactive approach is designed to preemptively avoid later disputes about cost and schedule impact when a decision is finally made. The GC must meticulously track all these details because, as one source warns, misunderstandings will occur without diligent record keeping of exchanges between designers, subcontractors, and vendors.
Constant vigilance.
It's a constant, painstaking administrative effort to keep everyone on the same page, both legally and practically, when conditions inevitably shift during the project.
So it's like writing the most precise multi-party agreement imaginable, where every I is dotted and T is crossed, knowing full well that any ambiguity, any unchecked detail will come back to haunt the project down the line. It's a testament to the meticulousness required.
Exactly. It really underscores the general contractor's role not just as a builder or a manager, but as a meticulous administrator, a shrewd negotiator, and a legal gatekeeper. They're translating complex technical requirements into clear, legally binding agreements that govern the entire multi-entity undertaking. They are the orchestrators of the contractual symphony, trying desperately to ensure every note is played correctly and on time.
Okay, so it's abundantly clear now that the modern general contractor isn't just a builder in the traditional sense. They're truly the conductor of this massive specialized orchestra. How do they actually manage this incredible feat of coordination on a daily basis? How do they make sure everyone plays their part in harmony?
That's the crux of their modern role, absolutely. If we connect this to the bigger picture again, the GC's position has fundamentally transformed into the top management function for the entire project. They are the ones who, as management guru Peter Drucker described it, see this business whole, balance present needs against future needs, and make those final and effective decisions when conflicting priorities inevitably arise between different specialists or goals. This is far more than just overseeing construction. It's integrated leadership on a really grand scale.
Integrated project leadership. That makes complete sense. They're managing the entire program, from initial concept through to completion and handover, not just segments of it.
Precisely. The GC provides comprehensive construction management services aimed at integrating planning, design, procurement, construction, and activation for a project. That reflects their holistic responsibility for the entire program management. It's a top-level view that requires deliberate adaptation of the project management approach, governance, and processes to suit the given environment and the work at hand. They have to customize their approach for every unique project. One size definitely does not fit all.
So let's break down those core coordination responsibilities. First, time management must be absolutely critical with so many interdependent teams and usually a very tight schedule. How do they juggle that?
It is paramount, yeah. The GC is responsible for establishing procedures for planning and monitoring compliance with the project timeline. This encompasses both the master schedule and highly detailed construction schedules.
And they dictate this schedule.
Not entirely. Crucially, it isn't just a top-down mandate. It involves on-site contractors in the development and updating of project schedules, ensuring their buy-in and incorporating their practical input on durations and sequencing.
That collaboration seems key.
It is. The GC actively seeks opportunities to recover schedule slippages, using sophisticated tools like the critical path method, CPM precedence diagrams, to track all those interdependent activities and identify potential bottleneck tasks before they cause major delays.
And technology helps here too.
Big time. 4D BIM scheduling offers a graphically rich and animated representation of the planned construction sequence set against time. This provides powerful visualization for all stakeholders, helping everyone understand exactly how their work impacts the overall flow and timing. It's a constant effort to keep everyone moving in sync.
And right alongside time, especially in a project with so many moving parts and potential changes, there's cost management. That sounds like a continuous battle to stay on budget.
Absolutely. It's a major GC responsibility. Tracking, projecting, and monitoring costs through the construction phase. This involves replacing initial line item estimates with actual committed amounts as contracts are awarded.
So tracking actual spending.
Yes, and meticulously managing change orders, which can add significant unforeseen costs if not controlled, and ensuring the project remains within the established budget and cost monitoring framework. The use of 5D BIM can enhance this by providing parametric and dynamic quantity takeoff for bills of materials linked directly to the schedule, meaning it offers a more accurate and dynamic approach to cost estimation and control as the design evolves or changes occur. It's about more than just keeping receipts. It's about proactive financial forecasting, control, and negotiation.
Quality is also paramount, as we discussed. How do they handle quality management across so many specialists who are each, theoretically, responsible for their own craft?
The GC monitors contractor compliance with the quality level expected for the entire project and ensures the work adheres rigorously to the contract documents, the plans, and specifications.
Holding them accountable.
Yes. While individual contractors are responsible for their own quality control within their specific trade, the GC plays a crucial oversight role. This often involves arranging and coordinating that field testing which is not a part of individual contractors' work scope. Things like independent structural integrity tests, material composition analyses, or commissioning of complex building systems to verify quality independently. They are the final arbiter of whether the combined work meets the client's expectations and industry standards.
This all really boils down to communication and collaboration facilitation between what could otherwise be disparate, sometimes even competing, entities on a site. How do GCs foster that spirit of teamwork? It seems crucial.
It's truly the lifeblood of modern construction. It really is. The GC actively facilitates proactive participation of stakeholders, including owner-operator, designer, contractor, subcontractor, suppliers, equipment manufacturers, and system integrators.
Everyone involved.
Everyone. They are responsible for ensuring that tools like BIM are fully utilized not just for design, but for coordination and issue resolution, including crucial clash detection between various trade models.
Finding problems digitally first.
Exactly. Literally finding where a pipe is designed to go through a structural beam before it's built, saving immense time, money, and frustration. Methods like formal partnering, which involve developing an effective communication system and a pre-agreed conflict resolution system, are also vital for success in this multi-entity environment. It's about building trust and open dialogue, not just buildings.
And finally, the ever-present shadow of risk management. In such a complex environment, risks must be lurking around every corner, waiting to trip up the project.
They absolutely are. The GC establishes methods and procedures to minimize the impact of claims and engages in a structured process to assess and analyze risks impacts, develop mitigation and contingency plans, and track these potential issues throughout the project lifecycle.
What kind of risks?
Everything from potential delays due to labor disputes or material shortages to managing subcontractor financial stability, insurance compliance, safety incidents, unforeseen site conditions. The list is long. They're constantly evaluating the what-ifs and developing strategies to minimize their impact should they occur.
It's clear that the GC's modern skill set is less about physically laying bricks or pounding nails, and much more about strategic oversight, meticulous planning, expert negotiation, and masterful communication. They are truly running a complex enterprise.
Absolutely. They manage the interdependencies, the 50,000, or who knows, maybe it's 50 million variables that exist in any complex project. The GC ensures that the specialized expertise of each subcontractor contributes seamlessly to the whole, bringing together these disparate crafts into a functional, beautiful, and safe structure. They are, in essence, the ultimate systems engineers for the built environment.
So this isn't a static system we're talking about. It sounds like it's always evolving.
Yeah.
What's next on the horizon? How will this story of specialization and coordination continue to unfold in construction?
That's a profound question, yeah. And if we connect this to the bigger picture, the forces of specialization and technological advancement are relentless. They will only continue to reshape the industry, pushing the boundaries of what's possible and, crucially, how it's managed. We're probably on the cusp of even more profound changes.
Okay. I imagine deepening digital integration and fabrication is a major part of that future. How will that fundamentally change the job site as we know it?
Without a doubt. The future points towards a world where digital fabrication capability and reach will improve by many orders of magnitude, allowing for a much more fluent transition from digital outputs to physical objects.
More automation.
More automation, more off-site manufacturing. What this means for the job site is potentially a dramatic increase in off-site manufacturing of incredibly complex components delivered ready for assembly, like Lego pieces, but on a massive scale. This will necessitate an even greater reliance on highly specialized digital fabricators who can translate intricate code into precise physical forms, possibly using robotics and AI. The act of making objects will become more like compiling and executing code than like laborious, specialized, and time-intensive woodcraft in a carpentry studio. So you might see fewer traditional craftspeople shaping materials on-site and more technicians assembling digitally manufactured, customized panels or structural elements.
Mass customization.
Exactly. Mass customization and on-demand production, further segmenting and specializing parts of the construction process, pushing the boundaries of what architects can even design.
And the relentless push for greater efficiency, less waste, more predictability That will surely continue, leading to more widespread adoption of things like lean construction methodologies.
Absolutely. The industry will continue to adopt and refine lean processes and tools like the last planner system and pull planning.
Could you briefly explain those?
Sure. The last planner system, or LPS, is essentially a collaborative planning approach. It involves those actually doing the work. The foreman, the crew leads in the detailed weekly planning process. This promotes reliable workflow and predictable performance because the plan is grounded in reality. And pull planning involves scheduling activities by working backward from a key project milestone, pulling work into the schedule only when downstream activities are truly ready for it, preventing bottlenecks.
Wait.
These methodologies are specifically designed to enhance collaboration, reduce wasted time, wasted materials, and improve safety, quality, and schedule performance by proactively managing the flow of work among all these diverse, specialized teams. Research already shows promising results, significant improvements in safety and quality metrics.
And with climate change and environmental concerns only intensifying, there will be an even greater demand for adaptability and sustainability in our buildings. That must open up entirely new areas of specialization, right?
This is a critical and rapidly growing driver.
Yeah.
Modern ecological imperatives are pushing for buildings designed not just for use, but for their entire life cycle, sometimes called cradle to reincarnation.
Cradle to reincarnation.
Meaning structures that are potentially convertible into housing or other uses down the line, and whose materials are recyclable or, even better, deconstructible.
Designed to be taken apart easily.
Precisely. This will necessitate entirely new forms of specialized design, material science, and construction techniques focused on that entire life cycle. Imagine specialists in modular design for flexibility, materials engineers developing self-healing concrete or bio-integrated facades that absorb CO2, or even deconstruction specialists who design buildings specifically to be taken apart and reused efficiently. It means building for disassembly and repurposing from day one, which requires incredibly precise, specialized knowledge that, frankly, barely exists at scale today.
So the role of the general contractor, the master coordinator, will have to keep evolving constantly to manage all these new complexities and emerging specializations.
It absolutely will. The GC's role will likely evolve even further towards that of a systems engineer, needing to understand and optimize the interlocking stocks, flows, and feedback loops of the entire construction process, thinking in systems as Meadows described.
Optimizing the whole system.
Exactly. They will be tasked with optimizing this increasingly complex adaptive system, potentially using AI and advanced data analytics to predict bottlenecks, manage resources more effectively, and improve decision-making. The formalization and critical importance of roles like the BIM integrator, the person managing the central digital model, will only grow, underscoring the GC's essential role in orchestrating digital workflows and seamless information exchange among ever more specialized trades. They will be the ultimate orchestrators of an increasingly digital, sustainable, and adaptable building ecosystem.
So the transformation from master builder to master coordinator isn't the end of the story. It's just one chapter in an ongoing narrative of innovation, complexity, and human ingenuity in problem solving. It's truly a testament to how we adapt to these grand challenges.
Indeed. The story of how buildings get built is a story of constant adaptation. It's about continuously balancing specialized expertise with holistic coordination to meet the evolving demands of our world, from medieval cathedrals crafted by hand to the smart, sustainable cities of tomorrow we're trying to build now. It's a never-ending journey of learning and building.
Wow. What an incredible journey we've taken today. We've traveled all the way from the singular, integrated vision of the medieval master builder who literally inlaid his name into his creations.
Yeah, amazing detail.
To the intricate, multifaceted orchestration performed by the modern general contractor. It's a world apart.
It really is. We've seen how powerful economic pressures, relentless technological leaps, and just the sheer overwhelming complexity of modern construction fractured that single all-encompassing craft into a symphony of specialties.
Right.
Each subcontractor now brings unparalleled depth of skill, from intricate structural engineering and advanced electronic security systems to cutting-edge HVAC design and sustainable material science. The list just keeps growing.
And crucially, we've highlighted how the general contractor's role has fundamentally shifted. They are no longer primarily direct builders in many cases, but rather master coordinators, the ultimate project managers. They navigate a labyrinth of dependencies, complex contractual realities, and daily communication challenges, ensuring that dozens of highly specialized firms work in harmony, all hopefully toward a singular shared vision.
From meticulous scheduling and sophisticated cost management to rigorous quality control and proactive risk mitigation, the GC acts as the central intelligence and often the primary shield for the owner. They ensure that every specialized piece contributes seamlessly and effectively to the successful whole. It's a continuous process of learning, adaptation, and intense coordination, driven by the need for efficiency, precision, and safety.
So the next time you look at any building, a gleaming office tower that scrapes the clouds, a bustling, life-saving hospital, or even your own comfortable home, consider not just the visible structure, but the invisible web. That invisible web of thousands of specialized decisions, precise executions, and diligent coordination efforts that brought it into being. It's really a silent, awe-inspiring testament to human collaboration.
It truly is. And it leaves us with a compelling thought for your own reflections. As technology continues its relentless march forward, as artificial intelligence becomes more sophisticated and integrated into design and construction, and as our global demands for complex, sustainable, and adaptable buildings become even more pressing, what new forms of specialization will emerge? And perhaps more importantly, how will we as a society continue to orchestrate that ever-increasing complexity to build the innovative, resilient, and maybe even beautiful cities of tomorrow?